All right, today we're going to do a demonstration on a new program that's going to lead us into one of the engineering projects that we're going to do later. The program is called Bridge Designer 2016. I'm not 100% sure that I have the same software on my computer as what you guys are going to have on the computers in the classroom. It might be a different edition, but the fundamental tools remain the same. To find the program, you're going to need to go to the lower left-hand corner, click on the window icon, and then search the list of programs that are installed on the computer. I don't think that there's an icon on the desktop, but I could be mistaken. But anyway, it's called Bridge Designer. It doesn't really matter which edition you use, but I'm going to walk you through getting started. So when you log into the program, it's going to give you an opportunity to either create a new or load a sample design. We're going to start fresh. So we're going to create a new bridge design. There's a few different things that we can do. We can change the height that our bridge is above the water. We can change the span that it has to carry. We are going to use the standard default setup, so you don't need to edit anything. We're not participating in the contest, so you don't have to worry about that. For the deck elevation, we're going to use the 24 meters, so you don't have to change anything. The standard abutments, the abutment of the bridge is the part where it meets the bank. We will not be using a pier, nor will we be using cable anchorages. So you can click Next. I would recommend you use the medium strength concrete, and we'll use the standard loading, and click Finish. This is going to bring up the default setup for where we're going to build our bridge. Now, to make life a little bit easier, you can create a template. So if we do load template, it's going to essentially write kind of a little light pattern for us to follow. Now, I'll tell you, it doesn't matter which of these templates you choose, but you need to follow one of them. We don't have the time to re-engineer a truss bridge. All of the trusses in the drop-down menu are proven. They've been engineered by civil engineers. They're in practice. Use one of these templates. There are two different styles, one of which is a deck truss. The deck truss has the truss underneath the roadway. A through truss has the truss above the roadway. Both are good. It doesn't matter which one you use. There's different forces that come into play on different pieces. We'll use the through truss, the Warren. So if you click OK, you can see that it's going to create a light template over where we're going to build our bridge. There are two really essential tools that you need to build your bridge. There's the joint tool where the pieces come together. So I'm going to use the joint tool, carry over all of my pieces, and place the appropriate joints in place. Then I'm going to come back and I'm going to use the component piece, and I'm going to connect each of those. Now, you do need to connect each one individually. If you were to try to drag all the way across, it does not actually make individual pieces. It makes one long piece and it will fail. So you need to do it individually. Connect all of them following the template. Do not add other pieces. Students typically want to add, other things that they think are going to be helpful. When you add additional components to the bridge, all you're doing is adding weight to the bridge, which is going to make it fail faster than what you want it to. All right, which means it's gonna fall into the water and won't be successful. Once we get the bridge kind of outlined, I want to point your attention to this piece up here. This program is going to calculate a cost of the bridge based on the material, the size. Right now, all of our pieces are 140 by 140. You can use solid bar or hollow tube. There are different properties make them better for certain things. And there are different types of steel. The carbon steel is the cheapest. The high strength, low alloy steel is the medium expensive. It's also a slightly higher strength. The quench and tempered is the highest strength, but it's also significantly more expensive. And we'll talk about when you may want to consider using the different types of material. To get started, we need to make the bridge function. So if I draw a big window over all of these components, I'm going to increase the size to 200 by 200. That should give me a functioning bridge. To test your bridge, you need to click on this icon right here. It says run the load test animation. When you click on that one, it's going to give you a rough graphic of a little truck driving over the bridge. You're going to see different colors coming into play. On the top of this bridge, you see that as the truck drives across, the components turn a red color. The components on the bottom of the bridge are turning blue. Now, anytime you're designing a truss, there are two forces coming into play. There is tension, which is pulling apart. To identify tension, if you think about pulling a rubber band and it's going to stretch. So these pieces on the bottom of the bridge are being pulled apart. And the pieces on the top are under compression, which would be like stepping on a soda can and crushing it. So these pieces are being compressed. These pieces are being pulled apart. That's important to understand because the different materials are better suited for tension or compression. So you'll need to identify which components work better. Now, some of these pieces you can see don't turn color very much, if at all. The darker the color, the more intense the force on that component. So these vertical pieces that are the bracing in the middle really have less force acting upon them. Now, the goal of our activity is to make a bridge as efficiently as possible. So right now, my bridge is at $575,000. Your goal for this activity is to build a bridge for less than $200,000. Okay, so it's really easy to make a bridge, but what I'm going to challenge you to do is create a bridge for less than $200,000. And in the next video, I'm going to give you some tips to help you accomplish that task.